Okay, today we're talking about percentage composition of mass, and this goes along with what we've already been talking about in 4.3.1.2. That's a mouthful itself. So yeah, this basically within this part of the specification you also need to know what percentage composition also means. Okay, so let's have a look at this. So percentage composition of a compound, essentially all that means is what percent of each atom exists within the compound. So if we had, for example, carbon dioxide, which I'm just going to write down here now, CO2, we need, if I was asked what is the percentage composition of carbon, that would mean how much percent of carbon is there within the whole molecule. Now we have a formula to calculate this, and there's the formula. Percentage mass equals the total AR of the element, which is the atomic mass of the element, divided by the relative formula mass of the compound multiplied by 100. So let's look at this example of carbon dioxide. So if I said how much carbon in terms of percentage is there in carbon dioxide, so the first thing I need to know is the relative formula mass. So the RFM, this is 44. Now we worked this out previously in the last video, so you can watch that again. It's just calculating the individual masses and adding them up. Now we know carbon is 12, okay, so 12 divided by 44 will give us a value of 0.27 reoccurring. Now I need to multiply this by 100 to get the percentage, which gives us 27%. Now that means carbon in terms of percentage is 27% of the whole molecule. Now that's the percentage composition of carbon within carbon dioxide. Okay, now let's look at some exam questions to practice this. So here we have calcium carbonate. Now the question is, what is the percentage of calcium within calcium carbonate? So the first thing we need to do again is get the RFM, the relative formula mass. Now this equals 40, which is calcium, plus 12, which is carbon, plus, I'm opening a bracket here because I'm looking at the subscript, there's 3 oxygens, 3 multiplied by 16, and this equals 100. Now if you're confused and you're thinking where are these numbers coming from, these numbers here, and that's from the periodic table. Remember the bigger number is the mass number, and that's what we're using. Okay, now we've got the relative formula mass. We know the mass of calcium is 40. Okay, so 40 divided by the RFM, which is 100, multiplied by 100, which is essentially cancelling each other out, equals 40%. So we can now say that calcium comprises of 40% within the molecule of calcium carbonate, or the compound. Okay, so there is 40% calcium in calcium carbonate, and that's the percentage composition. Now let's look at another example, slightly trickier. We have iron 2 oxide, it's iron 3 oxide, but there's 2 atoms of iron and 3 of oxygen. Now let's get the relative formula mass of this. So we know iron is 56, okay, and that's from the periodic table, but there's 2 of them. I'll open a bracket, 2 times 56 plus, that was the subscripts, 3 times, open a bracket, 3 times 16. When you do more of these, you'll eventually get used to memorizing most of the numbers. Well, I don't expect you to remember iron, but oxygen, 16 carbons, 12 hydrogen, 1, nitrogen 14, that type of thing. So the relative formula mass here is 160. Okay, here's the tricky bit. Now we need to find the percentage of iron. Okay, we have 2 atoms of iron, so it's, you know, a common mistake is 56 divided by 160. We're not doing that because there's 2 ions. We do 2 multiplied by 56, okay, which equals 112. Divide that by 160 and this gives us the percentage composition, right? Obviously we're going to multiply by 100. Now this equals 70%. So this is telling us that in iron 3 oxide, iron comprises of 70% of the total compound. So in terms of percentage, there is 70% iron in iron 3 oxide. Right, that's me done for now. Hopefully that helps you calculate percentage compositions by mass of compounds. I'll see you in the next